Hi, everyone. Welcome to the webinar today. We're going to just take a couple minutes to let everybody get settled and grab a drink or, anything you need to do to get ready for this great presentation today from Basic Power. So sit back and just relax for 2 minutes or so. All right, so we are at 1:02 p.m. Eastern Time. Hello and good morning or good afternoon to all of you from wherever you may be joining us today. I am Liz Mancini, Senior Manager of Member Services for AAPA. Welcome to today's webinar, Optimizing Port Electrification Through Power Quality Improvements, hosted by Basic Power. This is our final 2023 member hosted webinar. We are excited to have the Basic Power team on board with us today. Basic Power provides comprehensive power quality analysis to identify current capacity improvement potential in the existing electrification infrastructure of U.S. ports. We are excited to hear what our experts, Cedric, Steve, Jean, Cass, and Walter have to share with us today. We will be happy to take your questions at any time during the presentation, so feel free to post the questions in the chat or the questions area. We will be monitoring those as you think of them. So let's get started. I would like to introduce you to our presenters, Cedric Zewang, Stephen Washington, Jean Ostendorf, Joe Casciato, and Walter Scahan. I will turn the mic over to you, gentlemen. The presentation is now yours.
Okay. Hello, everybody. Welcome to the Basic Power webinar on port electrification. We really appreciate the fact that you've taken the time to join us here today, and we hope it is very productive for you. As Liz said, we'll take questions along the way, and if there's something we can't answer immediately, we'll circle back. I really wish, it is the holidays, I wish we could deliver everything you need to electrify your ports. That would be good, wouldn't it? But we can't. What we can do, however, is help you navigate what's going on with port electrification. We're going to tell you a little bit in this presentation on how we do that. We measure first, and then we make a proposal in short, and you'll hear some more detail around that. Things we measure, you'll also learn, and you may already have concerns about your harmonic distortion or grounding issues, but that's some of the things that we will talk about that we can help you with. We really look forward to next steps and some deeper dive meetings, and we hope you enjoy and learn how Basic Power can help you.
So Basic Power, we've been around for about 10 years now. We provide comprehensive power quality assessment with a specialty in harmonic mitigation, and we serve clients across the USA and the Caribbean. Our current projects include power quality improvements for the US Army through Honeywell, harmonic studies for Johns Hopkins Hospital, genset solutions for FEMA, and multiple projects in the city of Baltimore, including Baltimore Public Schools and the Department of Public Works. We are a UL 508A certified panel shop located within the University of Maryland's Biopark campus. And we manufacture power quality solutions here in Baltimore and also supply lab testing of filters and metering systems for other companies. So traditionally, our customers have been water and wastewater plants, cold food storage, and other heavy industry like manufacturing, pulp and paper, and oil and gas. So we're very familiar with the type of electrical loads that might be present at a lot of your port facilities and terminals.
So there is a lot of funding available. There's billions of dollars in the next decade going to support the ports for green infrastructure. It's probably not even enough. But there's an old saying, if you don't know where you're going, any road will take you there. We know you probably know more about the money aspect than we do, but what we're here today is to help you understand how we can give you additional insights on where to spend this money, the cost implications of it, the cause and effect of it, and hopefully that'll come out in the presentation. Thank you again for listening. I'm going to hand it over to Cedric, who is going to give you a little more technical information about what Basic Power can accomplish and how. Cedric, thank you.
Okay, so first, what we look into when we do a power quality assessment is to look for harmonic distortion, the nonlinear loads, grounding, generators, system capacity, transient phenomena, flicker, and utility billing. Now, a lot of these issues generally come from poor optimization in terms of the load and how they've been installed into the site, and it's just inherent design by the manufacturers. And they're not aware of the power quality issues that come about when you install these new equipment into the system. So first, let's talk more about harmonic distortion because it is one of the most damaging aspects of poor power quality and how we can help figure out a way to mitigate these harmonic distortions from damaging equipment. So harmonics in terms of how it damages motors. As you see here in this image, a regular motor can operate smoothly when you see a sinusoidal waveform, right? It operates in AC. But once you insert harmonic distortion into the system, you see that the motor would start rotating with a little bit of stutter. And that's because based on the waveform, you would see that in the negative direction, the fifth harmonic tells it to go backwards, while in the first and seventh, it'll tell it to go forward. So it's getting a mixed amount of signals to tell it to go back and forwards at the same time, causing it to stutter at rapid rates. Now, this stuttering can actually cause the insulation material within your motor to start wearing away, and that's when you get an arc flash event that can short and cause many like deteriorating damages to your motor. This heating can also desaturate the core itself and not just the windings. This will help in terms of how it will affect the actual motor. This will deteriorate the operation and efficiency because of the heating. Now, typically, the drive itself is called a variable frequency drive. Now, LEDs also have these drives, or ECMs, which are electronically commutated motors. All of these have a conversion from DC to AC. Now, when these drives have these conversions, in itself, that switching would cause harmonic distortion. And in any new system with new LED systems or VFDs or ECMs, typically you'll see a lot of harmonic distortion. And when you measure the waveform, you can actually see the 6-pulse waveform, which is that humpback that you saw in the motor previously. Now, typically, if you have a drive and a motor setup, you can install something in the middle. It can be the DC link choke or just an inductor to add some impedance, right? It's just to prevent the harmonics from reaching that motor specifically. It's like a shield to tell the harmonic currents to migrate somewhere else where it's not as easily maneuverable through that inductor. However, if you don't have any setup like this, the harmonics can just go straight through your drive and into your motor, and that's when you'll see that deterioration that we mentioned before. Now, this is a keen difference between VFD setups and ECMs. ECMs are compact motors. What they have are drives built within the motor, And the issue with that is because it's so compact, it's very hard for us to provide any filtration for that exact motor. Now, VFD setups are easier because they're separate from the motor and we can always add something in between to protect the motor itself. And the way that harmonic damages other loads, right, is that harmonic distortion can migrate within this closed loop system. Now, your harmonic distortion may not impact the motor itself. Like if you have a VFD paired with a motor, the VFD generates harmonics, but it might not directly impact the motor. But that can go back onto the rest of your distribution system and damage other sensitive loads. We've had several clients that had issues where harmonics are migrating from one load to another, and it starts cascading because you have a bunch of loads that are generating harmonics, and then in turn it'll resonate and receive harmonics from other places. And that's when you'll have systems failing and a lot of drives running into heating issues. Now, to mitigate this problem, generally people would use harmonic filtration. Now, if you look at this example here, you see that 6-pulse waveform that's humpback, and that's what the load is demanding. A way to fix it is that if you put something like an active filter, it'll measure the actual waveform that it needs to generate, and it'll create an opposite waveform. This opposing waveform, it's adding the wave together, or in this way, it's actually subtracting, and you'll end up getting a sinusoidal waveform when you measure again from that same point. Now note that this actually isn't changing the waveform of the load because the load is still demanding the same exact waveform. It's just that the harmonics won't look like it's going back to the rest of the distribution system. You'll measure a clean sine wave when you measure from upstream while allowing the downstream equipment to operate the same exact way. And the idea of having this setup is to, again, prevent the harmonic distortion from migrating between loads and upstream to affect other equipment like the generators, or even in your distribution, you have some transformer that might heat up and the lead times for those equipment might be super long. So we want to prevent any downtime and maintenance on those equipment by alleviating it from stress. And another way to alleviate stress is to correct your power factor. Now, the best way to describe power factor is like using the beer analogy. So here you have real power, and then you'll have reactive power. Now, if we use the analogy of a full cup of beer, right? The reactive power is the foam, while the real power is the actual beer. What you're paying for is the entire cup, right? So that is your apparent power and measured in kVA. Power factor really is just the ratio. It's the ratio between the actual beer you have out of the total amount that you paid for. In this case, as your ratio changes, your power factor changes. So this is a simple formula you can use when you look at your utility billing to calculate what your power factor might be. Sometimes your utility actually reports your power factor, so you can calculate your kVA or vice versa. The reason for this is because utility billing, they usually add additional charges when it comes to having poor power factor in your utility spendings. In this case, there are different names that it falls under, but one of which would be power factor correction charge, or reactive power demand charge, or kVA charge. They're just different ways to say the same thing. They're all billing you for the additional energy that you're demanding from them, and for them to make up the loss that they have to send that power to you, they'll just add that additional charge onto your bill. Now, not only will this affect the actual utility companies, but if you have your own generator, if you're in a closed microgrid system, or you're powering from a local source, this can actually help reduce your amount of fuel consumed during your operation. We actually conducted our own white paper study where we had this setup, where we had a generator and we had some flow sensors to measure the fuel consumed inside the generator. And by allowing us to change the power factor from being efficient to inefficient, we're able to detect the difference of how much fuel you consume. And as it turns out, there's roughly between 4 to 6% improvement in terms of fuel consumption during this operation of improving power factor. Now, this can lead to less hydrocarbon particulates emissions, and it lowers the amount of peak amps inside your generator. What that means is because we're reducing the amount of current you require to operate the same exact load, so you can have more space to put in new equipment if you need to. the problem with power factor is that if you happen to have a lot of amps put onto the same generator, and they're all running on poor power factor, you're missing out on that additional space that you could use if you optimize the power factor itself. And in turn, more current in the system means that there's more losses. There's more heating loss throughout the wires, and that's your I2R loss. You can also improve the cooling by dissipating all that heat, right? You're limiting the harmonic distortion, you're limiting the excess current from power factor, so you can allow for less stress on a generator and therefore it operates cooler.
And if I could just add something, the picture in the middle, the box, that is our unit. That's the Barabar unit, just for everybody's knowledge. That is our custom built solution in this case. So I just wanted to point that out, that Barabar is our product there in the middle.
Yeah, and another way to emphasize the benefit of just having good power quality is that you don't have to maintain it as much. It turns out that when we spoke with United Rentals, one of the main leading renters of generators, their experts are saying that they're constantly having to replace parts in their generators because of poor power quality, right? When it comes to harmonic distortion, they'll have to replace the engine heads, they have to replace certain parts because of heating issues and how it'll start vibrating violently due to harmonic distortion. So we can reduce the maintenance and improve the longer life expectancy of these equipment by just improving the power factor and the harmonic distortion. Now, the load benefit is that you will have an increased capacity, like we mentioned before, and you'll have less breaker trips because a lot of the times, if you have a lot of current running through your system because of poor power factor, you might run into nuisance tripping. Harmonic distortion can also cause nuisance tripping. So your equipment might suddenly stop working during the operation, and that might cause a lot of downtime as well. And we can also provide transient surge protection and voltage support to make sure that your operation runs smoothly, right? When surges come in through your generator, we want to ensure that it doesn't impact the operation itself and everything continues to run as intended. And if you're the owner of this genset, there's a lot of benefits, like we mentioned before, like less engine stress when load is conditioned. And you also have to run into less issues like stator rewinds because you're constantly having to maintain your generator due to heating. Like we mentioned before, the generators itself also has the rotor and stator example like a regular motor. So if you have heating in your system, the insulation will wear away, and the same exact issues like we mentioned before in the harmonic slides will apply to your generator as well. And the main benefits that I would like to highlight is, again, we can reduce the amount of diesel fuel consumed in your generators, as well as the carbon emissions, which is one of the main reasons for the Inflation Reduction Act, is to reduce the carbon dioxide emissions from your operations. And in terms of fuel consumption reduction, this is one of the graphs we were able to produce from our experiment. As you can see, the blue line represents an ideal load. What we have is a load center where we can decide how optimized that load works. It's a custom load center where we can choose what the harmonics are and what the power factors are. And we put it on a generator. We noticed that as we run it throughout the hours, it remained pretty constant when we had an ideal load. The moment we put on a power factor of 70%, meaning it's pretty much 70% efficient instead of 100%, you end up seeing that the curve is slowly building up because of heat, and you'll slowly consume more and more fuel as you run the generator longer and longer. And if you add harmonic distortion on top of that, you'll get an even larger consumption increase. So the benefit is we're removing the excess energy that is circulating inside your operation, and in doing so, you reduce the stress coming from the source, right, from delivering that energy to you. Whether that source is from the utility, they see the benefits on their end, or if you're doing this on your local generator, you'll see the benefits yourself on your generators. We actually have a fuel savings calculator, and this calculator depends on the make and model of the generators itself. Based on the values that we can find on a spec sheet, we can use it based on what we found in our white paper to calculate what are the savings that we can see, like how much gallons per day if you operate for 360 days a year, right? Depending on your diesel costs, we can calculate a financial savings and benefit from having this correction in the system. All these calculations were made using the EPA resource. There's a good tool that we used, which is allowing us to calculate the carbon emissions based off the gallons of diesel consumed. So we can directly correlate the amount of CO2 reduction based off how much gallons of diesel we save. And one thing to note here is it's very specific in a case-to-case basis. So in this example here, we're assuming that your load is running at 75% and your power factor is at 0.8, which is 80%. And assuming you're only running for 240 days in a year for about 12 hours a day and $5 per US gallon, these are the values that we get. And as you can see, we can reduce carbon emissions by a couple of metric tons over a year, depending on how big your genset is. And one thing to note is the more often you run your generators, the more savings you'll see, right? Because this is on a per hour basis. The more you run your generator, the more savings you'll see throughout the year when you're reducing that incremental increase from heating. And here you see what are the CO2 emissions reduced if you run it about 360 days a year, which is the only difference between the previous slide and this slide. Everything else remains exactly the same in terms of the parameters. Another thing to note is that in ports, generally you have a very large site and utility needs to deliver power to you guys. So the closer loads would be able to receive the voltage as intended, but the loads that are further away would start seeing a voltage drop. So if you have crane operations or any like motor applications or even HVAC at a site that's really far from your distribution, you start seeing voltage drop, and that can impact the torque or and even cause additional heating from the current draw. So the way to prevent this issue is that you want to provide a voltage support in the middle, and this voltage support can sustain that energy throughout the long distance, and you can maintain a relatively good voltage while you're operating from far distances. So if you fix your power quality issues, there's several benefits as we listed here. One is utility bill reduction, right? By improving your power factor, and depending on the utility, we can reduce the billing of reactive power demand or power factor correction charges. If you are using a generator or anything that requires fuel during the operations, your fuel consumption can reduce because we're eliminating inefficiencies in the system that will cause your system to operate using more fuel. And in turn, that leads into point 3, which is carbon emission reduction. As you use less fuel for your operation, you'll use there's less CO2 emissions in your system. And overall, the main benefit is to improve the operational reliability. Having good power quality can actually help reduce repair, maintenance, and even replacement costs. And knowing the lead time of our current economy, this is one of the most important points that we want to drive home. Now, in terms of deliverables, what Basic Power does is comprehensive power quality surveys, as well as manufacturing solutions ourselves. But when we see a site that has a lot of problems, what we'll do is we document every detail that we can find when we are on our site surveys, and then we'll provide a final report to summarize every important detail that the manager might need to know. And if there are any power quality issues, we'll provide the actual solution recommendations. And if they want us to help with choosing the right solutions and installation, we can also provide that in our deliverables. All this is following the AAPA standards. We want to make sure that we're in compliance with every regulations and guidelines to make sure that everyone's running their power safely as well as efficiently. And during this power quality assessment, this is generally the timeline of what it looks like. We'll first do a pre-diagnostic. What we'll want to do is identify the problem and understanding what the client wants in terms of the service, right? And it's identifying the electrical drawings, utility bills, generator information, or facilities management. Whatever the case may be, we want to find out what the goal is for the survey. And then after we complete our survey, we'll put in a power quality meter on site or several, depending on how large the operation is, and we identify any pain points during our survey. We'll then do an analysis. We'll first compile all the data, and then we'll look into every possible problem and recommend solutions for those problems in our analysis. And we summarize all that into a nice report where we can provide you some financial proposal and see what is the best fitting solution for your site. And as a result, after we do any installation, we'll do a comparison, a post-analysis, if you will, just to show that the benefits are exactly as intended, and you're seeing your, either the power quality improvement that you're looking for or the fuel reduction that you're looking for. Any questions?
Liz, are there any questions we're wondering?
Sorry, guys, I do not see any questions.
Okay. Well, let me just say, when
Anybody want to chime in? No? All right, go Kaz.
okay, well, we're pretty much done with the presentation. We could talk about a couple of things. I mean, what we're trying to offer the ports is the ability to understand where they are, and that's the survey. After the survey, when we put together our report, that report would include everything about your power quality issues, along with a recommended solution. Now, I can tell you there are some times where we make a recommendation that does not include our equipment. Sometimes we recommend a use of hardware or other solutions, but we want you to know that our goal is to help you optimize the spend you're going to need to make with the money that you're going to get to improve port electrification issues. And I know that's a big topic, it really is, but we also know that the ports want to be more resilient. You're being asked to improve your green infrastructure. All that costs money. We can help you by identifying how best to spend that money, and we're happy to do so. We really encourage you to reach out to us, and if there's any next step, deeper dive meeting, you want to learn more about how we do this, please let us know. We'd be happy to jump in and help you as soon as we can.
Okay, many thanks to our speakers from Basic Power for your topical and insightful presentation today. I hope you all feel like you gained something useful that you can take back to your offices from today's webinar. It concludes our presentation. Thank you for all your time and attention. And thanks again for our speakers for sharing your knowledge and expertise with us. I hope you enjoy the rest of your day. Enjoy your holidays. We have our next new member webinar on January 18th with Fujitsu. So look for your invite in your inboxes if you have not already received it. And thanks for today. Bye, Al.
Thank you very much.
Thank you.
Thank you.
Bye now.